Mechanism models like this often fail because the frames are built the wrong way. I will try to show here the same workflow I used on a real scissor mechanism carrying sliding doors with LED screens. Let's model it properly in Fusion. So we go with the new project, since the most important thing here would be joints, motions, motion study, many other features will be simplified. So we can start first. What I do, I usually save file, give it some name, project 1, let's say, and save. Now I start with the first component. Say OK, create new component, OK. Now we go to this plane and create sketch. Rectangle. Dimensions at this point are not so important, since we will many times edit dimensions, I guess. But I will put some dimensions, let's say 900 millimeters there and 900 millimeters here, or let's say 700 millimeters. So this rectangle, we will use this rectangle as a path to our sweep command. Now create the second sketch. Now since I have here a perspective view, I will try to have orthographic view here, and so you can change that in display settings, camera, orthographic perspective, perspective with ortho faces. Now I will create another sketch. We have that point there, so we will have frame consisting of square profiles 40 millimeters and 3 millimeters thick. So we have 40. Press tab so you can go to another dimensions. Press 40 and enter. Now let's center this middle point to this point here. So we used coincidental constraint, click, and it is now centered. Now in this, since let's say OK, since this is profile, we will add another square. So we will use offset command. Thickness, wall thickness will be 3 millimeters, so we will put -3 here, so that gives us a right direction. And we have now this second square. Our sketch is finished sketch. Now we can use sweep command, select this profile and select this path. We had some problem with selection there, but now it's okay. So this would be simplified version of the frame. Of course, this frame consists of square profiles. These profiles must be cut, must be welded, and when they cut and welded, it should look something like this. Of course, these edges here would be rounded. We can round them now using fillet command, but as we say, we want simplified version. So for our project, this is good enough. I wanted to show you also how you can use section analysis to see how your model looks in section, in cross section. So we can go to inspect, select section analysis, and now it asks us to select cut plane. So we can choose the plane along our object will be cut. We can choose whatever plane we want. At this point, I guess this would be okay. When we select the plane, we can select the direction of our cut. So let's say we select that, and now we have our model in cross section. So it looks like that. When we have a new folder here, it says analysis. When we want to edit position of our section plane, we can double click on section and move or rotate plane, and then click. When we are okay with the position, we can click OK. At this point, we don't need to see this cut, so we will hide, and we will use it whenever we want in our design. So we have this first frame. Now we can make some features on this. We can create some features on this frame. We will have slots, as you saw on the video at start, introduction video. We have some slots here, so axis can move along this slot. Also we have here, but at this point we will just create this. So again have something. So we had perspective camera. We again selected orthographic to see, because it's better to work in orthographic when we are creating sketches. Now we will have dimensions, let's say okay at this point. Now we will center this slot to center of this edge here. We select this constraint command, press shift, move along this line, and when this symbol appears, click on X, click on any of these points. So let's click on that, so this slot is centered to this line, centered to this profile. Now we will dimension this radius. It's 8mm radius, let's say, I don't know, maybe 11mm. Here we can say 100, and let's choose this dimension to be 130mm. So now we have sketch constraint. We can finish sketch. We want to make this slot, select this sketch distance. Instead of distance, we go to object and select this side of object, and it will create slots on both sides. Now we can create another sketch, and we again have this view as perspective. We want orthographic view. Now select circle, let's say 11 millimeters, but we will use parameter instead of this dimension. Let's center it to the middle of the profile. Dimension this 150. At this point, this dimension is not so important. Now we can go to finish sketch and extrude, or we from sketch I will undo this, Control Z, undo, or when we still in a sketch command, we can press E on keyboard and it will immediately move us to extrude command. So this is to speed up the process. Instead of distance, we choose to object, select this part of object, and we have this hole here. Now, as I said, we will use a parameter for this diameter here, but maybe it would be a bit of complicated. Now we have radius here, and there we have diameter. So it's D13. This parameter is D13, as you can see, D13. So we will finish sketch, and when we want to use parameter here, we set D13 times 2, because this is diameter and D13 is radius. Hope this is understood. So we have these two slots at this point, that we will use later. Let's save model. Now we will copy this component, go to here, Control C, Control V, and copy this component, and we will place it, join, and let's say we join this point and this point, but we will say that distance would be 600 or 500 millimeters. Let's say this at this point. So we will hide these symbols and go to object visibility and deselect joints. So we have this first component is grounded, and this second component we have a rigid joint to first component. So this is all grounded at place. Now we will create next component. Select this first component, so we will see a new different way of copying objects. Select first component. We can right click, copy, and now right click and paste, but no, not paste but paste new. So when we copy this component, we will be able to edit this component without editing this first component number one. So just to explain, I will go back in timeline, in history, before this copy paste. Now, as it is now, so when I change dimension on this first component here on sketch, let's say 500, we will have both of these components updated to this new version. But when we say paste new, as you see, we have this component that is not updated like these two, and we can change this dimension to, I don't know, we have 500 there, let's say 400, and click OK. So we didn't have to create this component 2 from scratch, but we just copied and pasted this first component, pasted as new object. Now we will edit this slot here. We don't need slot at that position. We will need only hole as here. But I guess we can use, we will select this component and say isolate. This is new thing, isolate. So we have only this component. We don't have to see all components in scene. This is simpler to work with. And we will delete this feature here, so this slot here, instead of this, we see here fx. That means this is function of some other elements, or this is equation, some kind of equation. We don't use it as equation or as parameter. We will say this is 22, or let's say 22. Press OK. So we will have new circle here. Let's say just put any dimension here so that we can select easier. Double click on dimension and click on this dimension of 22. Now we will have these both diameters the same. If we change diameter here, let's say 50, this will become 50 also. Let's undo this. Now we have to place this on the right position. Let's say similar to this, 150, and constrain this center of this circle to center of this circle. Now it is fully constrained. We have fully constrained sketch, finish sketch. Now go to extrude feature to update it and select this. Now we have two holes like that. We go to this component tool, right click, and isolate, so we can see all other components in this assembly, and we have something like this at this point. In next part of this playlist we will create joints and we will try to make this mechanism moves. Hope it will be interesting, hope it will be useful. So if this was interesting and useful to you, you can subscribe to the channel, like and share this video to your friends, family members or colleagues who might find it useful too. Thank you.